Welcome to the class. This is a short lecture, so let's talk about the function stack, how we manipulate the stack in your process to support the function call and function return. Okay, so we know we have like a couple like segments in our memory, virtual memory for your process. We store the source code into the text here. We store the global variable, static variable to here. We have some special parts, the heap to support the dynamic allocation. We also provide some like kernel stuff. So there's kernel information here. But most like common used one is the stack. Okay, so this is stack. Stack is common use one. Why? Because when we have local variable, we put into a stack. When we try to get some return value, we put on the stack. When we have arguments, for example, you pass a value from a function to another function, it's stored in a stack, on a stack. It's also a local variable on a stack. So we try to put a lot into information into a stack. So how it's actually work on it. So let's see this example, okay? So inside this example, we have three functions, the square, the do calculate, the main function. So first function is always the main function. When we run a program, your source code will try to figure out, okay, where's the main function? So actually, main function is the first one we push into a stack. So if we push into a stack, that's the main function here. And your stack will have a very special stack pointer. Like a stack pointer is kind of information inside process. Stack pointer point to the top of this main function. Okay. So I say top means it will go. Actually, this is go up, right? This is go up, but this is go up. But in the memory address, this is 0. This is the for example 4 gigabytes. So you can see actually when you go down in this picture, it's actually go up. Okay, so we push on the top. Okay, so this is the main function. So inside the main function, we can see we try to malloc something, we create something, then we create this do calculate. When we call this do calculate, we will call this function, right? We will call this function. So right now, this is the second function we need to push it to a set. So when we call this function, okay, so we try to get, okay, what's the return address? So we put some return address here to remember where I should return after I finish the function. Then I push this new function to calculate into this stack. And I update this pointer point to here. This is the top of your stack. And of course, to calculate, you need to copy a lot of information. Your value, okay, your t need to be here, right? So you have a couple like information here. And here we call another function. So we use another function. What's the function? We square. We have square. So square will call another function here. So this is the third function we need to put it. So we will put square here. Then of course, we also need another return value here to get like a which line I should return after I finish the square. Okay, we try to get some information here. And inside square, we just like process some value. And after, of course, we did not update. We should update this one to point to the top. And after the function return, we just pop. How to pop? We update the stack pointer point to a previous one. So actually, we don't get rid of any information here. We just like move the stack pointer a little bit up, okay? But you cannot guarantee every information here because they will disappear when you do another allocation, local variable allocation or other variable allocation. And of course, when you finish do cat, you will do function return. So you move the stack pointer, and everything here should be not used because you cannot guarantee the value is still there. Okay, so this is the main function. When your main function finished, then the program is finished. Let's see another example. Here we have a function yo. This function yo called function foo. So right now we know where's the stack pointers. Stack pointer is always point to the top of the stack. And the best pointers means what's the bottom of these pointers. It can help you to find out where you should move back when you finish your function. So we have your, and we call who. So we try to update EBP and ESP. So which means when we finish a who function, we will update ESP back to EBP here. Okay. So then you can like move around. You can pop. You can kind of pop this stack frame. Okay. So then we call MI. So when we call MI, we also push a new function on stack. Then we call MI again, we push again. When I call MI again, we push again. And after MI finish, I pop it. Okay. So when you pop it, you move your ESP back to your EPP. And you pop it, and you pop it. And right now we need to execute MI again, so we just do it. So this is a process how you manage, how your kernel manage this function call and function return. I hope you got the sense of how your kernel manage this function call, function return, how the kernel use the stack to support your local variable and the argument passing and return address, return value, this kind of concept. Okay, so hope you enjoyed today's video. Today is a short video, and see you next time. Stack function is awesome.